Hi Makla, how are you? Okay, today we shall derive an expression for instantaneous EMF induced in a coil rotating in a uniform magnetic field. ಇವತ್ತು ಒಂದು ಡೆರಿವೇಶನ್ ಮಾಡೋಣ. ಸೊ ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ಗೆ ಇದು ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ ಆಗಿರುತ್ತೆ AC ನಲ್ಲಿ, EMI ನಲ್ಲಿ. So you can expect for 5 marks. So the question is derive an expression for instantaneous EMF induced in a coil rotating in a uniform magnetic field. Makla, just understand what is called instantaneous EMF. Instantaneous EMF. EMF induced at any instant of time. How the EMF is induced? As you know well, according to Faraday's law, whenever the magnetic flux is changing, EMF is induced. Okay. Now, let us derive the equation for EMF, instantaneous EMF induced in a coil, which is rotating in a uniform magnetic field. Okay, Makla. So let us consider one diagram there. See, we have considered two magnetic pole pieces of Arshur magnet. Okay, those they are called cylindrical pole pieces. And in the space between the two pole pieces, there is one rectangular coil, as you know well. So this is a rectangular coil. This is a rectangular coil, as you know well. This is rotating in that space between the two pole pieces. Okay. Now, as we expect, since there is north and south pole, magnetic field existing from north pole to south pole. So it is shown in the diagram. B represents the strength of magnetic field between the two pole pieces. Okay, Makla? Now, as you know well, there are cylindrical pole pieces. They are not plain pole pieces. They are cylindrical pole pieces. Why the cylindrical pole pieces are used? To make the magnetic field radial in all portions of the coil. Fine. See, in the diagram, let us say N and S represents the poles of magnet. B represents the magnetic field between the poles of magnet, and theta represents angle between the direction of magnetic field and the normal drawn to the plane of the coil. And that normal is called area vector, because area vector is always normal to the plane of the coil. Okay, Makla? Now, let theta be the angle between A and B. It is very clear from the figure. Fine. So when the coil is rotated in the magnetic field, the magnetic flux linked with the coil varies. So as a result, what happened? As a result, EMF is induced in the coil according to the EMF, according to the law of electromagnetic induction. So let me say, now in the diagram, so look at the diagram, Makla. Illi ee diagram alli madhyadalli space ide, alli coil ಏನು ನೋಡ್ತೀವಿ. This is called rectangular coil. So as this is a rectangular, this is, no, remember, this is a cylindrical pole pieces. This is a cylindrical pole, you can imagine. So in the middle, there is a coil. So as a coil, this is, assume this is a coil. Okay, so like this. So it can be rotated like this. Okay, like this, it can rotate like this. Okay. So as a coil rotates, it cuts the magnetic lines of force. As a result, EMF is induced. Okay. Now, Ivaga, look at that magnetic flux. Let us find out the magnetic flux linked with the coil at any instant of time t is. That is given by, so by definition, the magnetic flux phi B. See, phi B represents the magnetic flux. The magnetic flux, phi B stands for magnetic flux, is equal to, you know well, magnetic field into area vector. So you should take the component of area vector in the direction of B. In the diagram, very clear, the component of A in the direction of B is A cos theta. Now that is given by phi B is equal to B into A cos theta. Athwa BA cos theta barkobodu. Okay, so this is for one turn of the coil. This is a magnetic flux links with one turn of the coil. Phi B is equal to BA cos theta. If there are n turns of the coil, we have phi B is equal to NBA cos theta. Or I can say phi B is equal to phi into B allado, it is phi B. Remember, it is phi B. It should be, nodi, idan ee tara baribekagutte. This is phi suffix B. Okay. So phi B is equal to NBA cos omega t, because I can replace theta as omega t, because by definition, omega is equal to theta by t. And what is called omega? It is called angular velocity of the coil at time t. Okay. Now, according to Faraday's law, EMF induced at any instant of time is given by definition, E is equal to minus d phi B. D phi by dt. E is equal to, nodi, we have this. E is equal to minus d phi by dt. So this is according to Faraday's law. The rate of change of magnetic flux gives the EMF induced. Now E is equal to minus d by dt of, substitute for phi B, magnetic flux, NBA cos omega t, or E is equal to minus NBA d by dt of cos omega t, because you can take out NBA out of the differential sign, we get minus NBA d by dt of cos omega t. So that we can write like this. Now E is equal to minus NBA. Now differentiation of cos omega t is very simple, minus omega sin omega t. So idu nanu nenpitkolbeku differentiation formula. So differentiation of cos omega t is minus omega sin omega t. Now write down that minus omega sin omega t. In the last step, minus minus it becomes plus NBA omega sin omega t. Put that in box. This is the equation for the EMF induced at any instant of time, and that is called instantaneous EMF induced in the coil. Okay. Adanna now bekadre E is equal to E naught sin omega t barkoli. Now what is called, now that equation can be written in different formats. See, V is equal to V naught sin omega t, or epsilon is equal to epsilon naught sin omega t. All these equations can be found. So here, where here it is called, nodi, E naught anta barutta. What is called E naught? E naught nothing but NBA omega, and that is called peak value of EMF induced. That is a peak value of EMF, maximum value of EMF induced. Now replace, avaga E is equal to E naught sin omega t. So this equation represents the instantaneous EMF in the coil at any instant of time. Okay, Makla. Suppose if R is a resistance of coil, then the induced current in the coil is given by, you know well from Ohm's law, I is equal to E by R. I is equal to E by R. I is equal to E by R. Now substitute for E naught sin omega t by R. Now I can replace E naught by R as I naught. Nodi, E naught by R and I naught barkoli. Avaga I is equal to I naught sin omega t. Okay, makla. So this equation represents the instantaneous current in the coil. Nodi? Okay. See, from the equation E is equal to E naught sin omega t, very clear that variation is sinusoidal. So that means the value of EMF or instantaneous EMF varies with the time sinusoidally. Sine graph tara change agutte anta. So adanna graphical agi bariti nodi. If you plot a graph of EMF along y-axis and time along x-axis, you will get a curve like this. Look at that, where E naught is called peak value of EMF induced. So this is a graphical representation of variation of voltage or EMF with current. Okay, makla? So it carries 5 marks. So ishtana neevu chennagi odkolbeku, and nodi, this much you have to write down. Okay, this much you have to practice the diagram. So illi neevu enu extra questions na assume madkobodu antandre, why the cylindrical pole pieces are made curved anta keltare. The cylindrical pole pieces are used just to make the field radial in all positions of the coil. And also, inside the coil, there is a soft iron. Soft iron is used in the coil to make the field more intense and strong. So, soft iron and use madkonbitre, a coil olige magnetic field strong agutte anta navu itkobodu. Okay, fine. So, this is a derivation that normally asked in the PU board exams. Okay, Makla? Fine. Hope you understood this derivation. So it may be for 5 marks. Okay, practice ಮಾಡಿ. ಆಯ್ತಾ, ಈ ತರ ನಾವು videos ನಾನು upload ಮಾಡ್ತಿರ್ತೀನಿ. So kindly make use of these videos and subscribe the channel. Okay, so that you will get the notification whenever I upload the video. Thank you. Thank you. And shortly I will move on to another video. Okay, fine.